Hello, everybody. So, for night two of SF 200. I guess this is the first real night. The other day was syllabus day, so course policies, and then just filling time with previews, kind of seeing some of the stuff we'll do. Uh, there is a lot to Java. We will barely scratch the surface in this class, but hopefully, good foundation for it and better understanding of what's going on. Most people these days start coding with Python, which everything about that is to make it easier for the human. And one aspect of that is that we lose a whole lot of control. So we want to learn about that stuff. Um, Basically, the list for tonight is just to start looking at basic syntax. There are two prerequisites to this course. So y'all understand logic, we just need to see the syntax for it in Java. So I was going to start doing some examples with that. Talk about primitive types. Might go ahead and get into methods. Pull up these notes in case I want to look at them, but yeah, basically a whole bunch of trivial examples here, and then your assignment submissions are going to be made to GitHub. So we do want to look at putting files onto GitHub. You need to see that somewhere along the way tonight. So I'm going to just go ahead and start NetBeans. For some reason, it's not into my taskbar. I should get that to the taskbar since that's what we'll be using in class. So while this starts up, y'all remember way back in your SDEV 120 class and talking about the binary numerical representation of integers, floating point numbers, and then booleans, which is binary representation is just ones and zeros. And then at some point, hopefully whoever you had for the class pointed out that Python does not have those. That's called primitive data. Right? We learned about those 8-bit integers, and if we try to store the number 8 in Python, we quickly learn that it's using 64 kilobytes of RAM. It's like that doesn't seem like it matches that lecture that we just said through. We do have primitive data here. And primitive data is handled a little bit differently. That's the examples from the other day. You can get those out there. And we'll be talking about Maven. You're probably going to do most stuff in Java with Maven because Java is for big things that typically run on servers, and servers still mostly use hard disks because they last a lot longer than SSD drives, especially under heavy usage. But as far as class examples, if we go to look at things in the folders and whatnot, there's a lot to dig through in Maven. So we'll see that soon. Most of the class examples, I'm going to use AND. This was kind of the first one made. What is this? This is basic syntax. That sounds like a good name for a project. And notice here's where it said create main class. It has basic syntax in all lowercase letters, and then it does that, throws in that Pascal case version that I mentioned. Names are very important. The compiler and Java virtual machine do keep track of those names. So we have to pay attention to things like that. So that's the name of our project. I'm going to put it someplace different here real quick. I'm going to go over to the NetBeans project. I can go over to the delete folder. And yeah, I'll just put it in here. Something called basic syntax. Maybe I'm going to add one more folder to put it in. We'll get to the reason I'm putting another folder here later this evening. Where's my new folder right there? I'll call this class 2, our second class session, and then I will create the NetBeans projects for this evening in that folder. And we'll put that folder on GitHub later. Well, that's the reason that I wanted to put that in another folder. So this folder will eventually become the repository at the end of the night tonight. And then we'll slow that up to GitHub. Which You'll notice under the team menu here, there's the Git version control. There's also mercurial and subversion controls. Those are the second and third most popular one. Git is like 99.6% of programmers use Git. So number 2 and 3 on that list are way, way down in popularity for our version control system. This is an older one though, so generally it's best to start it in your regular file explorer thing. We'll see that use the most recent version of Git over in your file explorer when you recently installed, and then all of the functionality built into the IDE will work. It does that thing. This one will still use the old name for the default list. Throw this out. This out. Get all this clutter out of the way. Comments are useful, but in a classroom example where we're following along, comments are just kind of clutter getting in the way. So I mentioned back in the SDEV 120 class, we had those lessons on what the basic numerical representation of data. And we do have that primitive data here. So if we want to use only, our go-to is generally going to be int. So strictly typed language, we have an integer. We want to do math with integers. We have to say we have an integer, and that sets aside some space in memory, 32 bits in this case. So it sets aside 32 bits, and it is a 32-bit one. So number 1, I'll spell it out. So Java naming conventions are to spell everything out. I kind of took it to the extreme that way. It is okay to use digits, but that was the first 2 words I could think of there. Spell the variable names out in camel case, variables and methods in camel case, and don't abbreviate things. That was one of the first things they did in Java back in the late 1980s when C++ was first becoming just an incredible mess. By the early 1990s, it was an unwieldy monster nobody could keep straight. And that was long before the days of search engines. One of the conventions they set up with Java was don't be lazy with typing, spell everything out explicitly. Spell everything out fully. Typing is easy. And also these days we have predictive text. So once we type it once, it's going to show up on that predictive text list. So integer number 1 is going to be assigned some number. Let's put a 34 in there. And I'll just do a couple integers. Second number, 21. So there's a couple numbers we can do, look at our basic math with, and all of our data types are going to be like that. With primitive data, there is a slight difference. Once we get to strings in a minute, I'll draw a picture to talk about the difference. The math is probably what you would expect for all of them. So if we want to add stuff, if we add 2 numbers, what is the result going to be as far as type? If we add 2 integers, what do we get back? Still an integer, right? So the result of adding those is going to be an integer. I'll call it sum of numbers. And while you're doing your homework, try to come up with long variable names, long descriptive ones. Before the end of the semester, we'll see what I sometimes refer to as essay length variable names. They get really, really long. Some of the ones built into the language. I did stop and count one of what was it? Fall of 2019, we did stop and count one of the objects we were using. I think it was 38 letters long. Fully spell everything out. Typing's easy, and with predictive text, we really only need to type the first couple letters of it. Some of the numbers, this probably would have been your first guess, right? We add those together, and then we want the operating system to access. We want to access the output stuff from the operating system, and we'll just do a basic print line. numbers. Probably no surprises there, right? I hit run. All works. I'll take a second and make a quick change before we go a little bit further. So, okay, that works. Have this basic syntax package, and then, oh, look at this name. There might be a better name for that. Like main would be a really good name for the starting point, right? This is our main class. So your first thought is we're in a text editor, so probably good to just type that in. But that is something you never want to do. If you haven't seen this before in your editors, have y'all heard the term refactoring? Did you see that in the previous classes? That's cleaning up your code. It's not debugging, it's your code's oftentimes going to be a mess when we put it together. Our variable names be scattered all over the place, inconsistent spacing, cleaning it up, and renaming falls under that category. So if we want to change a name like this, instead of just changing the name, you're going to right click on the file. Put him in the Zoom call. Come over here and right click on the file, you'll see there's a refactor option. Anytime you rename things, you want to use the refactor option. Name here. Or right over in your code, if you highlight it and right click, you'll see there's a refactor here. And when we use this rename, it will search through all our code and actually change the name. So let me, for example, let me just type that in there. It's like, oh, I want to call that main instead. But notice that it caused an error right away. Class main is public and it should be in a file called main.drop. That is a restriction. Our file name needs to match the class name. Notice that if I hit run now, it can't find the main method. So undo that, and I think this will rename the whole file and everything. So I right click and refactor and rename it and call it main here. Notice it changed the file name, and it also changed things in the background. If I come over to the project, right click and come down to properties. Under run, notice the main class, the point it actually started at, it didn't even change the name over here. So if you just type it in, you have to go through and change it you have to go type it in a whole lot of places. And there's a really good chance you're going to miss one if you have to type it in. Well, with what we have going here so far, it would need retyped in 5 places. So there's a pretty good chance you would have missed that just trying to retype a different name. So you want to make sure and use the refactor button anytime you change names and things like that. Now it should still work the same. I wanted to point out that button very, very soon. So adding, subtracting, multiplying, dividing, most of those probably straightforward. If we subtract 2 integers, what do we end up with? And we're getting used to the conventions. Try to type with some long names like that just to get used to it. Again, it shows up on predictive text, so you really only have to type it the first time. Especially if you're careful about what the first letter is. If you're careful about the first letter on all your variable names, then you'll be able to pull every one of them up really quickly from the first letter. No surprises there. Oh, how do I do that? I meant to use the variables here. Let me put the variable names in there since we already stored those things. I don't know why I overtyped that. If you notice anything that seems like it's obviously a typo, please speak up. Because I'm talking and typing at the same time, so typos do happen. Difference, multiplying is the same, right? If we multiply 2 integers, we don't add any fractional values. We don't get any decimals from multiplying two integers. So it'll give us an integer. Product number one times number. We'll do exponents. Yeah, I'm gonna jump ahead and do exponents. So exponents, if we're going to square something, like if we wanted number one squared, we could just take number one times number one. But if we wanted it to say this time, we need something, some sort of operation. If we do an exponent, it gives us an integer, right? So that's going to be the biggest change from getting used to thinking of the static types all the way through type of data we can get back. Excellent. And for this, we need to use a library. You may have seen the caret used before. The little thing above the 6, that's actually the symbol for how we measure joules. But usually, for some reason in America, we actually write out CT instead of the actual symbol for it. But the caret is, that's just a coincidence. The caret is an XOR operation, and it is just a coincidence. And that in binary, if we do XOR binary, two binary integers, two positive binary integers, we get the same thing as if we would have done. So to do that, we need to, it's actually built into a library. It's not one layer down. So math operations are other use for static. Anybody remember what static means? Talked about it the other day. We use it in a few places. See Larissa thinking about it.
It is right on tip of my tongue.
So in normal English, static means non-changing, right? There's one copy, only one. Oh, there's only ever one copy. So if there's only one copy, then we can use the one in the blueprint, not an instance of it. That's why our starting point has to be static. But what about math? Would we ever create an instance of an object? Our math's always going to be the same, right? We don't need particular details on how we run the things built into the math library. So the math would be a static object. We can make a static object. We don't need lots of copies of a math object. One will serve all of our purposes. And that is what's built into the language. So math with a capital M because it is an object, so Pascal case. And it's a static object. We don't have to create a new math an instance of a math object. We'll talk about object-oriented programming a lot more soon. I'm just want to make sure and use that word. An instance of a class, or when we instantiate a class, that's called an object. Remind you all of things from previous semesters. But when we instantiate things from that design, that blueprint, that's where we add details, right? Like in a subdivision, we build all our 2-bedroom ranch homes from the same blueprint, but each object built off that blueprint has little details that are different. There's no need for that in our math class. Any math we want to do, they're all going to be the same. So we'll use a static object, and to do that, we just ask for the class name directly. The one here is power, right? So exponent, the base number raised to a power, and then we enter them in that order. So math, not power, math.pow. This one was created at the very first. This is one of the very first things that was created. Math library. I make a big deal about the naming conventions, but there are a couple things that didn't follow the naming conventions. Arrays as well. Arrays broke out of the naming and away from some of the other conventions because they were the very first things they did when the guys sat down and started to started to create the first universal remote. And then quickly, the things they did before they realized they needed to clean up the programming language. So I would take on for one of those first things. So what do we want to, so we'll raise number 1 to the second number power. This looks like it doesn't like it though. The little message box popping up there is very clear about what's going on. Incompatible types, possible lossy conversion, and questions in the calculator show. I think those numbers, I think those should be big enough. So if I take 34 raised to the 21st power, calculator tells me that's 1.44 times 10 to the 32nd. So 1.44 followed by 30 zeros. It's a really big number. In Java. And ints are big, they're 32-bit signed numbers, 2's complement numbers, has a maximum of 2 from -2 to the 31st, 2 to the 34th. But which is bigger, 2 to the 31st or 10 to the 32nd? So that number we just asked for, 34, which is our number 1 raised to the 21st power, is too big to fit into an integer. So we also have long integers, which are quite a bit bigger. Why does it like that? Double cannot be converted to long. Oh, it's returning a number, a double. Okay, I'm gonna make it a long because I know that's gonna be an integer. This method is overloaded, so it's expecting that maybe we want a floating point number. Y'all can quickly see everything we've done so far and notice that we haven't got floating point numbers yet. So to convert that to what we call casting, changing our types. Sorry, I take that wrong. Long is primitive data, so the primitive data does start with lowercase letters. It is camel case on those. So casting, which is our term for changing type, what we do is in parentheses right before the thing we want to change, we put the type we want to change it into. So let me put a comment on this one. Long type of data, cast math results into long type. So to cast between different types, just put it in parentheses right beforehand. Strings are an exception. Strings are kind of built in because they expect the programmers are going to need strings. So strings are easier, but any other type, we just put it in parentheses right beforehand. So this gives us a double. We'll turn it into a long because we know we have integers here. I just went from the calculator to check. 10 to the 32nd power is bigger than 2 to the 31st power. So it's too big to fit in an integer. We have to pay attention to things like that. I guess we can print some of these out. So I'm gonna do S out. And this is a shortcut that's different in every single IDE we use for Java. Because system.out.println is something we're going to type a lot. So all of our IDEs have a shortcut. So if we type S out and then push the tab key, that's the shortcut for system.out.println. And if you don't want the line break, it's a lot quicker to come back and delete the LN than it is to try to type that whole thing out. Only with line break. And so some concatenation. Let's print out these results. We want sum of numbers, and concatenation can be a plus sign, which are probably no surprise there. Then I'll concatenate in a comma, and then difference of two integers. Control space. Plus, notice I started typing and the predictive text isn't coming up. And that means control space pulls up your predictive text. That's fairly standard across most of our editors. But no suggestions, that's because I forgot the concatenation. So we have number plus a string, which is just a comma to separate them, plus, and now we should get the predictive text. Yeah, I hit control space and then it didn't even give me the list. It's like there's only one thing that you could want in that in this case. Plus another comma, plus get Zoom calls out, Zoom pictures out of the way. What's next? The product plus I just hit control space. If it's ambiguous what it might want there, you would see the whole predictive text list and choose between them. But we're in a print statement in an IDE that has been building for over 20 years. Well, I just installed NetBeans version 18. Right? It takes a while for something to get up to version 18. So by version 18 of the software, the print statement knows we want our variables from our code. It's not going to show the whole random list. Plus another comma, plus excellent. There we go. In that end of instruction. Oh, oops. Last part was already typed in there. I just didn't see it because I didn't scroll over far enough. Hopefully, no surprises with concatenation. All that makes sense. And there's the results of those. And those are primitive data. String is not primitive data. If we wanted a string, because I'm going to go ahead and put a picture on the board here pretty quick. A string, a character is primitive data, right? Y'all remember that from the SDEV 120 class? Or ASCII code or the extension into Unicode. Java goes with Unicode unless we change it, but it's really, really easy to change it to any other encoding scheme that humanity knows about. Java had over a 2-decade run as the most popular programming language in the world. So any encoding scheme that humans have thought of is people have brought it into Java at some point in those couple decades. Characters are primitive data, but a collection of characters is an object. That's something more than just those basic bits. So a string, I always call it label. And there's a couple ways. We could just put the new string here. I'm going to use this syntax. We want that to be a new string. With strings, it's common enough. We could just throw in our quote marks and type it in there, but I want to go since we're at the very beginning. Most of the time we'll do it that way. We'll use the shortcut. But at the very beginning, I want to show this syntax. This is what we use most often. String type of data, some name so we can ask for it later in our code. It's going to be a new something. And then this is the constructor when we get to making our objects next Tuesday. Making our objects then we'll talk more about constructors. That's one way we can instantiate objects. In Java, we also have factories. We won't see those until about week 6. A factory it spits out lots of disposable objects. So instead of making that one really fancy thing off the blueprint, our class knows a design for an object, instead of making that one instantiating that in one really fancy object that we're careful with all through our code and carry along, a factory spits out a bunch of disposable objects and spits them out and deletes them as needed. So they're disposable. Like if we want to call a method, we'll have a factory spit out a new instance of that object, run the one method, and then delete it. So the next time, if we need some data that we store in a particular object, and have that same factory quickly spit out a disposable one, use the one thing we need from it, and then throw it away. So we also have those. We have multiple ways to create that. If you look at like memes and things about Java, you'll probably see a lot of things about factories. One of the classic jokes, programming jokes, is that a programmer had a problem, so he tried Java. Now he has a problem factory. That's where that comes from. Which is a great way to learn when you're learning a new language. Make sure you check out things like the memes and jokes and comic strips about them, because they help, and you want to make sure you get the jokes about the language. So that's going to be a new string, and we can add the string inside of the constructor. I'm going to put our results, and then I'm going to print that out as our label. Print out the label, and then we'll print out all those results. Because these are handled very, very differently. And I'll draw a picture on the board. When we're typing in our code, it's treated very similar, right? We just use this word for our object, and we use this word for our primitive data. The primitive data, it is handled differently on the inside of Java. So if you go to like look into Java certifications, which I did put the information in module 8 about that. Put a page in module 8 as a link to the Java Foundations certification, ISO 811. It's not a bad certification. We will see this course very closely aligns to that, except for the modern software development tools that we'll look at in modules 5 and 6, REST APIs and frameworks. So here's that picture that I'm going to be drawing a lot, and by the end of the semester, we'll be making stacks, and you'll have a thorough understanding of what a heap is. So we have a couple things. I'm going to use the X and Y's on the board as for the string, because it's kind of hard to do really long variable names on the board. So our integer, we call it X. So we have this integer X, and an integer is primitive data. So maybe over in our code, where do we got? We'll say int X equals 5. That's an easy one. Yeah. That points to the spot over here, and it's primitive data. So integers, 32-bit number. We also have a byte. Let me do that. That way I can do the full thing. Byte is also a type of primitive data, which hopefully y'all can guess pretty quickly what a byte is. So 8 bits, 1, 2, 3, 4, 5, 6, 7, 8. So a 5 would be 0, 0, 0, 0, 0, 1, 0, 1. So it's actually storing the number 5 right there. Our primitive data, so we have this byte called X. Well, we see what X is. But we also have a string. I'll call it S. No, not S. That looks like a 5. M. Message. Here's that shorthand syntax I was talking about. We can just say that a string, some reference equals, and then put a string right there. We don't necessarily have to have new with string, because string's so common. So this one's a little bit different. Most of our stuff in Java is objects. We can tell it's an object because of the capital S here. So whoops, I called it M. M also has a pointer over to RAM, but what it points at is another pointer. So this is a string. So Java has what's called a string pool. So it's going to set up a spot strings are something we're gonna use a lot, right? And we're gonna need a lot. So as soon as we start up the Java virtual machine, it asks for a whole lot of space to store strings. So in that string pool, it's gonna add message. And that, at some spot in RAM. I'm gonna make up a number, let's say that starts. The start of those Unicode characters is at bit. Start at bit 175. That's probably kind of a small number, but it'll fit in the box here. So over here in this thing spot, the Java virtual machine reserve called the string pool. We stored that string, so then what this one points at would be primitive data. I'm going to write the decimal here, but it points at the spot that points at that. Very different things, but they behave in different ways. So only our primitive data is pointed at directly, and anything else we point at an integer that refers to its address in memory. And string pool is kind of important because that's worked into how Java works. There's lots of questions about that on that certification exam I pointed at. If we made another string, I'll just do N for the next letter. And if this was, I don't know, words, we set a spot up for it. It gets ready to point at something, and then the Java virtual machine is going to go over here and check the pool, and it's going to look through every single thing in the pool. Okay, words isn't there, so it's going to add words to the pool. Maybe this is bit 2, would be bigger than that, 510. So it finds a place where it sticks it in there, and then that reference we made points at 510. Make another string. Let's make another byte. Byte Y, and I'll put a 5 in this one as well. So Java has really, really good memory management. So it's going to set this thing up. It's like, okay, we have this primitive data storing a 5. Oh, it's right here. So it doesn't need to make a new pointer. It can just point at that one that already exists. It's already there. Which actually goes even further. Maybe instead of 5 there, if I put 510. The only one we stored was 5. But 510 is pointed at already. So it's gonna be like, oh, that's already in our code. That's already in here. We don't need to store 510 a second time. And same thing with the string pool. If we made another string, MN, I'll just put this one as S. And put words again. Over in our code, it's going to set up our reference value. And then when it starts it's going to check the pool and notice that that's already in there. So there's no need to create it again. So it will just create a pointer back to that same spot again, which is this one.
I have a question.
Yes.
So I know in Python, this is also like kind of not really related to this, but I've been sitting here thinking about it. In Python, you can like set, run code, just pick a number between 1 and 50. You just have to give it, a random, like, can you do that here, but also specify that you don't say that you don't want even numbers. Pick a random number between 1 and 50. But
the selection structure. The selection structure. There might be one built in, but I don't know of a built in. But it's a really easy selection structure. Because as far as logic, let's go to her example. That'll introduce a couple things in the basic syntax. Does that picture make sense?
yes.
Kind of a complicated one. we're gonna do stuff like that, talk about what's going on in RAM, and there's really, really, really good memory management here. In many years of coding in Java, I've only encountered 2 times where I had to go in and mess with memory management. And one of them sloppy code on my part. I used a bunch of anomalous objects, so there weren't any references. I just left it through the CPU to figure out. And garbage collection couldn't figure out when things were done and when they used again. So then RAM just kept piling up, and whenever we hit 90% RAM usage, it dropped every time. So that was just sloppy coding on my part. But that's the only time I've ever had to deal with memory management. Going and deal with memory management directly in Java. So very, very useful. Okay, so random numbers, there's a couple ways. There's one in math. So we could use the math library and do math.random. That's the one that gives us a number 0 to 1. There's also a random library. We haven't done any imports yet. So let's look at, so to, I haven't do it down here. I'll come down to the numbers. So it's a random type of data. And we haven't imported anything yet. I want to show useful keyboard shortcut. I started to go type it. Then I was like, wait, this will be more useful. So random, I'm going to call it rand. It's a new random. So this is just an instance of our class. Everybody knows what an object is. So we have this object that has a whole bunch of methods for working with random numbers. Cannot find the symbol. It's not part of the, it's not part of
Like what you
the
previously.
default. Yeah, it's not one of the, it's not the basic Java in out. The most basic, only a few things are in that we can do without importing any other libraries. So to import here, in NetBeans, it's Control-Shift-I. So if we push Control-Shift-I, it typed in this line. Almost all IDEs do that. Yeah, that probably seems like an extremely fancy thing, but pretty much all IDEs do that. This is why I don't count VS Code as an IDE. If it had auto import off the bat without doing a bunch of fancy stuff, same thing with Sublime. All that stuff's there. We have all kinds of things, everything we need to write code, but we actually have to type our import lines. It can't figure out what to import immediately. That's where I draw the line, but at the same time, I have also been known to call NetBeans and Eclipse text editors. Because that's really what we're doing here, right? We're just editing the text file. So it is still a text editor. That was the style I chose. So there's some plugins, some roundabout ways to do it, but they're still more complicated than they need to be. So Control-Shift-I, or you can just come type it, import. So using Java before, or using Python before, everybody's probably used the word import. That's different in all of our languages, but Python and Java happen to use the same word, same version word for it. C# we would say using. C++ we would say include. JavaScript is kind of it's overly fancy in JavaScript. We set up a variable equal to a function and different syntax, but we have all these things that are part of the library that we can use. So the Java language obviously has a bunch of utilities built in and whatever. Okay, sorry, that took a long time to answer the question, but did that?
Yes, it did. Thank
and
you.
And then Control-Shift-I is the auto import in NetBeans. You can also go to preferences and just have it do it automatically. So when you ask for an object, it'll go ahead and do that. Let me undo real quick. Personally, I've found that that's really neat at first, but before long, it's not going to be long until it imports the wrong library. Especially if it's something like Node. There are lots and lots and lots of libraries out there that have an object called Node in them. There's a good chance that if you have it automatically set up, the computer's going to get guess wrong from time to time. You know, if I come over here and click the light bulb to make sure you choose the right option. And if there's more than one option, you'll see a list of what to choose from. So I would highly recommend keeping it on the keyboard shortcut, not the fully automatic, but that's just preferences. It's the checkbox that says auto import. It's not how we want it. Now we have that, we can make a new random number. We haven't seen the floating point numbers yet. So our go-to floating point is gonna be a double, whoops. Lowercase d, it is primitive data. 64-bit floating point number, we also have 32-bit floating point numbers. Unless we need to start worrying about those extra 32 bits. Most people go with doubles. For instance, game engines. Right? Any game engine you're running 140 to 180 frames per second, those 32 bits are going to add up a whole lot of time. 32 bits, 140 times a second is a whole lot of extra bits that don't need to be there. So then we would probably start minimizing it. In general, most people go with the double though. So double sort of data. Number is that random object, and if we hit dot to get to the predictive text, we see what's here. So the next float, next double, next Gaussian, next int, next long. So we just choose the next of a particular type. There's more things down here. I was just going to use the random method. I'll use next double because that's what they're there. Let me come back, go to that on the line list, and notice the documentation pops up here, so you can read. You don't have to go to Google and look for it. If the documentation pops up right here. The next two are random, uniformly distributed double value between 0.0 and 1.0. So basically a probability. 0 is included, 1 is not included. So if you think of it as probability, the absolute certainty, it never gets to absolute certainty. So 0.99999, however many 0.9s we can fit in the 64-bit number is the highest one, and 0.0 is included. So in terms of probability, the definitely won't would be included, but the definitely will happen would be excluded. That's fairly standard, so no surprises there. It tells about the method, what it returns, gives us a nice long description. Not everything has that long of a description. Obviously, random numbers are something that they expect is going to be used in the classroom, so that has an extra clear description on what it does. Oh, now we want to see if that's even. Oh, actually, I didn't really answer the question then, did I? You guys about even numbers.
No, but I get the same preface. It would just be the opposite if it was.
A little bit different. So random even is ran next int. And notice there's multiple next ints. Mm-hmm. So next int is a large range, or next int with an upper bound, or next int with a lower and upper bound. Which one you want to use, Larissa?
The upper.
Around. So next int, and let's say somewhere up to 100 or something.
Yeah.
Even numbers. Okay, so that gives us a random number between 1 and 100, but it's not even. Mm-hmm. So this is where our if else will come in. Actually, we can do a loop. A little bit out of order here. This would probably be best to do it. Maybe a loop on. So we have that number, and I'll do a while loop. We're gonna see 4 loops very soon. I assume everybody has seen both of them before, at least your third programming course. 4 loops are for when you know how many times it's gonna happen, right? It's gonna happen. Like if we knew it was gonna take us 7 tries to find an even number, we would use a for loop because we know it's gonna run exactly 7 times. While loops are for when we don't know in advance how many times it's gonna run or if it's gonna run at all. So while random number or random even number you know how we check even numbers? I think so. Some of y'all probably know this, right?
I knew it at one point, but I need a refresher.
So if we just think it through, what's the definition of even number?
It can be multiplied by itself and still be an even number.
That is included in number theory. But it's a multiple of 2, right? Which means we can, if we divide by 2, it divides evenly. And what does it mean to divide evenly?
It not be a decimal, it's a solid number.
No remainder. Good. So we can just check that. If we do modulus by 2 and the remainder is 0, then we have an even number. But really, we just need to do this loop if it's not even, right? So if we divide by 2 and it's not, the remainder is not 0, which the only option would be 1, but at least the way my mind thinks, the not makes sense there. So there's our symbol for not equality, while modulus. So you can see this goes a little bit faster than other syntax. So we're looking at basic syntax this evening. So if anybody, after we go through this example, if anybody else has questions like Larissa asked, feel free to pop those up and we'll just do that for our example. We do want to keep it simple, somewhat unclever with examples, but we want to see all these things. So if we divide by 2 and the remainder is not 0, then we have an odd number. So in that case, we can just take random even number and assign that the next int with an upper bound. If it's not an even number, let's try another random number. And before long, we should have an even number. And we don't know how many times it's going to take. But it might never run at all. If we get an even number the first time, I think everybody knows what happens if the condition's already met, right? If it is divisible by 0, then it's just going to skip the while loop, so that would never run to begin with. That's when we want to use the while loop, when we don't know whether it's going to run or not. S out, and then we can say random even number, and control enter pulls up your predictive text, but if you're in your print statement and do that, I'm going to take out the print line and just build up a string just for some variety. Some say print, which obviously prints without a line break. So you have a bunch of things you can do that. Random even number plus a tab, like backslash T to tab over, backslash S, put tab and then a couple spaces, backslash B, and we'll backspace, we'll take away one of those spaces just to work that example in somewhere. So tab, space, backspace. Is an even number. Probably can't tell from how that here, can I? Oh yeah. So if I push right once, see it jumps over the whole horizontal tab, and then right again gets space, and then /B is the second backspace. That can be really useful if you're like printing things out and putting commas between them. You just do that in the loop and then hit backspace at the end to get rid of the last comment. Instead of putting a fancy condition to try and tell if you're the last one or something. We do have we can type in the backspace character. Even number. Probably do what? Yeah, if y'all have any questions that would lead to little examples like that, feel free to ask them how to use syntax. Let's try that with a so there's a pretest loop. Oh, Did she leave? Thought she was already here. Okay.
It'd be okay if I remember extremely fast.
Yeah, let's go ahead and take a break then. So good time for a break, because I don't know what I think, I'm like, maybe when they call, so I'm gonna look into that. And probably a good time for a break, so let's take 10 minutes. My clock says 6:59. We'll be back here at 7:09. And I need to figure out why it's not letting her in the Zoom call. Zoom call's working, right?